Okay, so good night again, everyone. My name is Duvania, and this session tonight will be in preparation for the Cape Unit 1 Geography exam, and paper 2 is first. So this session will really be looking to target past paper questions from paper 2, and of course, looking to identify or rather clarify any topics or any challenges that you guys might be having. So right off the bat, I'd just like to start with a past paper. And I'd really love for this session to be very interactive. So don't be afraid to open your mics and, just let me know what you guys think the answers might be or the thoughts that you guys have towards a particular question, because I tend to find that once you participate a lot and you interact more, the questions kind of become easier and you kind of are able to, figure out everything a little easier. And you might help someone else as well. So I'd love for us to start with, I'd like to do the 2022 papers. So 1 second, let me just pull this up. Okay, so is everyone seeing my screen?
Yes.
Okay, so all right. Okay, is everyone good with map work? Or would you like me to go through that as well? Uh, just a reminder, I'm sharing the screen, so I won't be able to see the chat.
You can go through it, please.
I can go. Okay,
Yeah.
all right. Okay, so based on how I tend to do questions, or rather when I was doing CAPE, I kind of left the map work questions for last. So I'll just go through the rest of the paper and then we'll come back to the map work question. Okay, so I mean, this one isn't. All right, so we could start from here. We could start from here. So part part I for question is asking to name the non-climatic coastal hazard illustrated in figure 2 right here. So does anyone have an idea what this could possibly be?
Tsunami.
Pardon?
Is it a tsunami?
Okay, yeah. That's what I also had in mind. It's a tsunami because it asked for a non-climatic coastal hazard. So when you're looking at a diagram like this, you might be thinking that it could possibly, be a storm surge, but that would be a climatic coastal hazard. So for this, you'd definitely be looking at a tsunami. And for sure, you have to pay attention to the clues that are, of course, given in the question because it distinctly asked for a non-climatic coastal hazard. So a tsunami would also be something very fitting that you could look at. Yeah. Okay, so what are the two causes of the tsunami that you could possibly think of here? Anyone? Feel free to open your mics.
Underwater volcanic eruptions could be one.
Okay, great, great. And another one?
What
Seismic
about
activity such as earthquakes.
Pardon?
Seismic activity such as earthquakes.
Right, yes, yes. Those would be the two main reasons or causes for a tsunami. Does anyone have any examples that they could possibly think of a tsunami that probably, people always talk about, or a country rather that's prone to a lot of seismic activity and resultantly tsunamis? It's it's a country located in the Eastern Hemisphere, in the north to be particular.
we use
Japan.
Thailand?
Okay, yeah, Thailand could be one. Well, but sure. But I was thinking of Japan because I think I remember doing some past papers and they always tend to refer to Japan. And also that's just something, that's usually typical. Like if you're thinking of anything related to seismic activity or tsunamis, for example, Japan is normally a good country to use for a case study for that, right? Okay, so doing good. All right. This question now. Outline 4 possible socioeconomic impacts of flooding on settlements. Does anyone have any ideas what this could be looking at?
One could be the loss of like houses and the loss of property and agriculture because
Right?
yeah.
You can explain, you can explain.
I was
Just
gonna say,
ask
okay,
to outline, right?
if flooding were to occur, then a lot of agricultural areas or plains or whatever the case may be would also be flooded, and in the process, crops would be destroyed as a result
Okay.
of that.
Okay, great. So that's one. So that's loss of property and agricultural produce. So you're also looking at, its impact on livelihoods as well, because you mentioned the whole agricultural aspect of it, right? So for settlements, right, especially settlements that have been created, or rather communities that have been created around arable lands where, they're close to rivers because the floodplain tends to be very fertile. A riverine flood could cause the loss of crops and of course have negative impacts on people's livelihoods. So we spoke about the impacts of livelihoods, spoke about the loss and damage and loss to property. Anyone else?
I know that disease is not a socio-economic reason, but if you explain disease in terms of flooding spreads diseases such as I forgot the name of the disease, but it's like with rats and stuff. If you explain it as like an extra cost on government to take care of people.
I think her connection went bad, or was that it?
That was really it. Like if you even though disease is not a socio-economic impact, if you explain it in terms of it being economically impactful on the government to take care of the people affected by the disease caused by the flood, if you would still get marked for that.
Okay, right. Yes. So we'd be looking at health implications for that one. So, you would have, for example, you could use cholera or like typhoid. I believe typhoid is also a waterborne disease. So you'd be looking at the health implications, for if there should be these waterborne diseases, because flooding could cause, let's say, for example, there is a reservoir nearby to this settlement, right? And there's a massive flood, and the reservoir gets filled with, the murky and unsanitary floodwaters, right? If the reservoir isn't, properly cleaned, don't do the right chemical tests, on the water, and people are using this water for domestic purposes, you could be looking at health implications and, as basically the rise in waterborne diseases that would be taking place. So yes, health implication is one. That's a good one. Also, you mentioned the government, right? You're talking about, the strain that it would put on governments to kind of eradicate such a widespread outbreak, or to rather prevent a widespread outbreak of a waterborne disease. So yes, that would be something to note as well. So that's why it's also important for governments to ensure that they have, funds in place for when there's some sort of disaster, so that they can be able to and so that it can be able to protect citizens in terms of their health, their livelihoods, help to pump money back into the economy, so that, you don't end up with like a massive blow to the economy, or to the economic structure of the country and particular communities. I think we've gone 3, so one more. Okay, so all right. Pardon?
Loss of businesses and property.
Loss of businesses and
Property, like
property, right? Yeah, we touched on the businesses in terms of the livelihoods. So, can you think of anything else? Is anything else coming to mind?
I feel like we could split the businesses and property into two separate points, so that it would we could like move on, and we have before. Property would be like you could link that to agriculture, and then business, sorry, could be linked to agriculture, and property could be linked to like housing and stuff.
Mm-hmm.
Wait, I have a question, right? Would mass migration be another point as well, like for areas where there's like consistent or like frequent flooding in certain
Mm-hmm.
people might be like propelled to um leave, or that might be a push factor for them
Right.
because
Yes.
they can't like
Yes.
maintain their livelihood there, because every time they try to build something, it always destroyed by the natural disaster.
Right. Yes. That's a good one. So that was one that I actually made a note of. It could cause mass displacement, right? Because if people are constantly losing their property, right? Their houses are continuously being damaged. They're continuously having to, deal with floodwaters, right? Then that's a massive push factor for them to, pack up and find somewhere else to go. As well as, you could also look at it in terms of it could cause an increase in homelessness, right? Because if, let's say, someone is residing in a particular community and there's a massive flood, and they aren't able to basically cope with the damages. They don't have enough funds to probably rent somewhere. They don't have any relative that is willing to, accommodate them for a period of time. Then you're looking at this person possibly being homeless. So those I would say, that, along with the stuff that we previously discussed, are what I would consider to be some of the socioeconomic impacts of flooding on settlements. So we touched on loss of property, we touched on, the loss of livelihoods, we touched on it being a push factor for persons to leave the area. So you're looking at that community or that settlement being completely destroyed, because there's no one there to really live there, so it wouldn't be classified as a settlement. And of course, we spoke about the health implications. So this place will now be, unsuitable for people to live in, because if every time it floods, there's an outbreak of a waterborne disease, or even mosquito-borne diseases as well. For example, if the flood waters do not, uh, recede, or they don't flow overland fast enough and kind of the levels go down, then you're looking at stagnant water, and that's also a breeding area for mosquitoes. So yeah. Okay, so moving on to the next question. All right, so name the type of map that is used to represent regional population density through the use of various shadings and colors.
Choropleth.
Correct, yes, the Choropleth map. And the question, I believe, asks, yes, to state one advantage and two disadvantages of the type of map, of the Choropleth map. So can anyone think of any advantages?
I think one advantage would be that because of the contrast and shading, you can clearly see which area has a high density compared to which area has a low density. So in terms, it's like it has a good visual representation, basically.
You're right. Yes, that's one. Can anyone think of any other one? Any other advantage?
Is easy to construct.
Yeah, that's also one. Yeah, it's fairly easy to construct. Yes. Okay, so that was two advantages. So, you could just pick whichever one you like and make note of that. Disadvantages. Okay, so I'll give one. So one of the main things with the Choropleth map, so I'm not sure who just mentioned that it's easy to construct, but which is an advantage, but considering that you're easily able to just, come up with different gradation for the colors that you want to use, right? On the key, it's oftentimes what you find is that it doesn't really accurately show the variations that would take place across space, right? So what it does is it technically assumes, or rather shows someone who's looking at the map, that, let's say you're looking at a Choropleth map of Jamaica, right? And you have all the parishes, sectioned out and stuff. What it does is that it will make it seem like an entire parish would have the same value, right? Throughout, which is necessarily most times not the case, right? There's spatial variations which should be accounted for that a Choropleth map does not. Does everyone get that? Is that one good? Or
But I have a question. Right? When you say like spatial variation, meaning that
Mhm.
like in terms of the map, it basically showing that there's like a consistent number of people throughout, and they're not showing like the difference in different areas, like the different number of people in different areas. That's
Right. Yeah.
okay. Okay.
Yeah. Yeah. So that is exactly. And building off that, what it also does is that it shows that when you're approaching an administrative boundary, so for example, a parish border, right? So you're looking at the transition from one parish into the next. It will basically kind of show an abrupt change. So let's say that for Jamaica, again, you're looking at a Choropleth map, and you're seeing where, you're looking at Kingston and St. Andrew and St. Catherine, right? Kingston and St. Andrew is Kingston is fairly, but it's the most dense parish. KSA is the most dense area that we have in the island. And then St. Catherine is almost there, but it's not that as dense as Kingston, right? So moving into St. Catherine, you'd find that there is this abrupt change. So let's say on the Choropleth map you have, for Kingston, hypothetically saying you have it at 500, right? And then St. Catherine would be, let's say, 250. Moving from Kingston to St. Catherine, it's going to show an abrupt change, which is not normally the case. It takes its time and it would have a more, like, it's more of a, I want to say it's like a change, it's a gradual change. So it's not this hard and fast line that the map would typically show. Because of course, there are reasons that would account for certain changes in settlement patterns, or why there's probably not a massive concentration of people at certain points or certain areas throughout a parish. So basically it shows an abrupt change, which isn't normally the case. Okay, so this next question, define the term carrying capacity based on human populations. Does anyone want to have a go at this one?
But carrying capacity we refer to as the optimum population, where it is the natural resources in a state of equilibrium with the number of people within that specific population.
Okay. All right. So you're basically saying the maximum number of people that the environment's resources can support while remaining in equilibrium. That's what you said.
Yeah, basically.
Okay. All right. Yeah, that's a good definition. Can I ask you why you use the word equilibrium though?
I don't know, it's just a sociology term, and usually what has happened is that, it's just a balance. So I just use the word equilibrium because
Right.
I don't
Yeah.
know.
You're not wrong. You're not wrong. So it's to maintain a level of balance, which is right. But also you want to make sure that you're not the maximum size of the population that is being accommodated by the environment isn't causing damage to the surrounding environment. So you're able to achieve a level of sustainability. So the definition that I have here is the maximum size of a population that can be supported by an environment, considering the rates of resource use and waste production that can take place without causing damage to the surrounding environment, thus achieving a level of sustainability. So what this means is that you'll have let's say you have, the environment could only support 1,000 people occupying one space. These people are making use of the resources, whether it's water, land, space, they're farming, they're doing everything. And of course, they're generating waste. And as well as they're also participating in other human activities, right? You want to ensure that you're not causing damage, especially permanent damage to the environment where it's not able to replenish itself. Because now you're gonna find that you're pushing the space into like this zone or this state of depletion, and then you won't be able to, the environment won't be able to sustain any life. All right, so you'd have exceeded the carrying capacity in that case of the environment. So is that good with everyone?
Yes.
Okay. All right. So the next question is looking at how an increase and a decrease in human population size and resources can affect the carrying capacity of a community. We could go with, let's go with human population size first. So both increase and decrease. So anyone wants to have a go at this one? All right. Let me see something. Okay. So can anyone give me 2 ways by which population size can increase? Or the population size of a community or an area?
Migration.
Migration, right? And another one?
High birth rate.
Pardon?
High birth rate.
High birth rate. Okay, so natural increase then, basically. So, all right. So if you have a population that is growing in size, what would happen? Like, will there be a higher demand for resources or a lower demand?
A higher demand.
Right. Okay. So basically, once there's an increase in population size, and you could give an example by way of natural increase, migration, or immigration, anything of the sort, it will cause a demand for resources. And if there's a demand for a resource, what's gonna happen to or rather, if there's a high demand for resources, right, what's gonna happen to the environment? Would there be a strain or would there not be a strain?
There would be a strain.
Right. So there's going to be a strain on the environment and of course its resources. So eventually the area might become, unsuitable for people to live there because if you're having remember, people are always using resources. Like we're always using water, we're always occupying land space, we're always using things from the environment to carry out our activities, right? So if there's a constant demand that is being generated and people are always taking from the environment, it's gonna eventually deplete the resources, right? Because remember, the the resources that we have on the planet are for the most part finite, right? They like, and for the ones that aren't, they tend to have a very long time for, replenishment to occur. So you're gonna have people constantly using all these resources because there's a high demand, putting a very high strain on the environment. And of course, the area might become unsuitable for habitation or unsustainable because, there's a high demand for resource use. The environment isn't able to replenish in a fairly quick enough time. And of course, you're basically depleting the resource, right? And then on the other hand, a decrease in population size would lessen the demand for resources. And it therefore means that there'll be a reduced strain on the environmental carrying capacity of the area. Okay, so if you notice in that discussion that I just gave regarding human population size, I mentioned resources a lot. And then the next question is basically asking you to talk about how an increase or a decrease in resources would affect the carrying capacity of a community. So would anyone like to take a try at that one? I'll give you some time to think about it.
So I was thinking in terms of resources, if there
Mhm.
if if a country has, like our community has a lot of resources, it is able to sustain a higher population. So more resources equals bigger population, whereas with less resources, yet it cannot sustain a large amount of people. So I was thinking of it like that. Is that correct?
Right. Yes. 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 So basically, an increase in resources would automatically lower the strain on the carrying capacity of the area, which makes it more readily available and suitable for persons to occupy the space, since there would be enough resources to sustainably accommodate every individual, right? And if the opposite happens where there's a decrease, of course, again, heightened demand, lowering carrying capacity. Okay. So again, remember, guys, you can stop me anywhere along the line if you're having any difficulties or any challenges. Right. So now the models of urban land use, I know this tends to be a topic or rather section or rather a section that a lot of people tend to have challenges with. And I think one of the main things is it just comes down to you know, them having, like, you have so many different types and then to remember a lot of the information, right? So what's useful is if you could kind of you know, look at the diagrams and kind of have an understanding or probably find like a unique attribute to each that you could um ascribe to one of them or to each of them rather, and it might help you to remember it. And especially if you're someone who tends to rewrite your notes or, you know, rewrite definitions or anything like that to be able to remember, you could try practice drawing some of these diagrams as well. That might also help. So there let's just step away from this question for a second. Can anyone name the three, I believe there are three models of urban land use that is on the syllabus, this one and two others. So can anyone name the models of urban land use?
I think this one is named the sector model by White. There's also one called the multiple nuclei model, I believe, by Ullman and Harris. And then there's the concentric. I'm not sure what's the rest of it, but I know that one is the concentric, and that is by Burgess, I think his name is.
Yeah, Burgess, yeah.
Burgess. Yeah, okay,
Yeah,
yeah.
yeah.
Nice, nice.
Okay. So yeah, so you remember how I was saying you could find like different, like maybe attributes that you could ascribe to each of them. So for the Burgess one, it's the concentric rings, right? So it's literally a bunch of circles going around, right? It's literally a bunch of circles going around. So that one is Burgess's model. So whenever you see one with literally rings, concentric rings, it's Burgess's model, right? And then you have this one, right, which is Hoyt's sectoral model. So yeah, this one. And then you have the multiple nuclei one by Ullman and Harris. So those are the three that I believe, yeah, were touched on. I would say that probably the multi-nuclei one is the most challenging. Okay, so could be the most challenging one because that one I believe it's more split. Like the sectors are split up all over. So okay, so in that case then, so we all agree that this model right here is Hoyt's sectoral model. Is that a yes? I think it's a yes. Okay, all right. So then in that case, which area would be the high class residential area?
I think sector 5.
Right. Yes, sector 5. and the wholesale or light manufacturing,
Sector 2.
right? And the CBD,
Sector 1.
right? Okay. And another important thing to note is that you could always identify similarities amongst the models, right? Similarities and differences, because it also might help with potential essay questions. Because what if they asked to compare, right? Compare Burgess's model versus Hoyt's sectoral model. You'd want to be able to talk about the similarities that they possibly possess, right? And just being able to identify or just being able to differentiate between the models alone, I think you could get a couple similarities there. One of them being that they both have, the central business district in basically the central area of their models, right? That would literally be something that you could talk about. Them prioritizing the location of the CBD. Ullman and Harris's model, I mean, it's a bit different. So I mean, I wouldn't readily say like you could just easily identify and say, whatever, but between Burgess's and Hoyt's model, that's easier way to, if you're probably in the exam or you're trying to think, what could they possibly want me to talk about? Just simple things like that would be something that you could easily talk about. All right. Okay, so next question. Would you guys prefer to just do the paper as in with the essays and stuff going right along, or leave the essays as well for last? Okay.
I wouldn't mind leaving the essays for last.
Same.
Okay, leave the essays for last. Okay, cool. So you could always come back to that. So when we're finished with the paper outside of the essay questions and the map work, we're gonna just take a short break so you guys could, get some refreshments or, stretch your legs a little, and then we tackle the essay questions. All right, so 2 characteristics of a water table. I kind of found, I'm not gonna lie, I kind of found this question a bit odd because I've never heard anyone say characteristics of a water table. But I mean, it's a question, so anybody like to have a go at it?
Miss,
Or
I
the
have
possibility? Yeah.
so I had the water table is the boundary between the saturated and unsaturated zone
Right,
of
yeah.
soil moisture. So
All right. So I pretty much have that as well. So the only thing I would add is that it's an underground, right? So just want to put that in it as well. That it's located underground. So it's basically an underground boundary, right? The next question, not question, sorry. The next one, the characteristic. Okay, so what I have is that the shape and height of the water table is influenced by the land surface that lies above it. So I kind of figured that could be a characteristic of it, that the shape and height of the water table is influenced by the land surface that lies above it. So yeah, right. Okay. So the next question is looking at this diagram here. Right. Figure 4 is basically showing a cross section through a water table. So they asked us to label X and Y. Let's go with X. Does anyone have any ideas to what X could possibly be?
The aquifer.
Aquifer. Okay, so the aquifer. Does anyone else have any ideas to what X could be? Okay, so all right. This diagram, I can understand that it could be a little tricky because when I was also working this paper, I was querying like, okay, because to me, I was thinking that it could have been two things, right? There could have been two different options for both, for both X and Y. So, but what I ultimately decided on was that X could be the cone of depression and Y would just be representing the water table itself. Yeah, those are what I was thinking. My alternative options, I'm not sure if how well those would phase out because I was doing some like throwing around the ideas in my mind between if they would be wanting to talk about it being the zone of saturation or the zone of aeration, but I don't think that's what, because Y is clearly pointing to the water table itself, right? This is literally the line here where Y is, the dotted line where Y is literally pointing to the water table. And I would, considering where X is placed, I would think that it would be for the cone of depression that would have been created as a result of the use of the well that's here. So I'm not sure if anyone else worked the paper and got those responses.
I got those. I got that as well because I was considering it because in the diagram in the book, when the water table, like things like that, they call it the cone of depression. So I had the cone of depression fact as well.
Right, yes. Yes. Now, what I'm thinking if maybe should they do over or rather give another diagram similar to this, right? And it's not showing the cone, but rather you're seeing, let's say X is pointing to more so on this area here that is above the water table line. And then let's say the cone is not there, but they're indicating that there's water present underneath, right? It would more than likely change towards it being the zone of aeration and then the zone of saturation at the bottom. So aeration at the top, saturation at the bottom. But for this, I would go with Y being the water table and X being the cone of depression. Right. All right. And basically, if you're wondering what the cone of depression is, it's basically, as in the name, the cone that's created as a result of, the use of the well, or there being like extraction or pumping of the groundwater resources. So it sort of causes the, okay, if you could picture there being like a long pipe that is going into the groundwater, right? Into the aquifer. Or yeah. Once the pipe gets there, it basically is going to land in water first, right? And then as you're extracting or as you're pumping water out of that area, eventually the water level is going to decrease, or it's going to recede and go down and go down. Now what happens is, remember everything, as we were discussing earlier, everything in the environment likes to be in balance or maintain some level of equilibrium, right? So you're lowering the water, the height or the level of the water, and it's going down, it's going down, it's going down because you're continuously pumping, and it's not really being recharged as fast, or the rate of recharge isn't as quick or on par with, the rate of extraction. What happens is the soil layer that is located there sort of gets depressed, because it's gonna sort of cave, like how this diagram is showing it here. It sort of caves. And what that does is, because remember, the entire area would have water. So on both sides of the pipe, there would be water as well. What happens is the water now there's a gradient that would be created that the water flows down. So hence you see here the arrows that point and says water flow. So there's a sort of gradient that the water would flow down. And this would be kind of like the cone, right? That would be created because the water is now flowing, downwards towards this pipe. So it's flowing downwards towards the pipe that, would be attached to the well. And this would still allow you to be able to get water from the well, because if the water didn't flow down, or if the cone of depression wasn't created any at all, once you receive the level of water from that you'd be pulling from, once it recedes, you wouldn't be able to get any more water from the well, so it'd be useless. So that cone of depression kind of creates or facilitates you to be able to continuously get water from the area for a period of time. If that makes, I hope you guys kind of are following with that.
Yes, miss.
Okay, great. All right. Now this next one here, again, on human population. So with the current increases in human population, regions that depend on groundwater may over-extract water from wells. Using the features identified in B part I, describe how active pumping at well sites affect the water table. All right, so. Okay, so I think how many marks? 4 marks, I think probably between two to four descriptions could work for this. So I'm assuming it'll be 2 marks for each description. So okay, so any ideas for this one?
Miss, could you give us an answer? Because genuinely, when I was doing the paper, this question had me a bit like, because I don't really like this topic. So
Okay, that's fair. That's fair. Okay, so the most or the easiest feature. Okay, so let's look at the water table, right? So if you're constantly extracting water from, or you're constantly extracting anything at all, right? Taking away from it, it's gonna cause, of course, the resource or whatever it is to be depleted, all right? And in this case, if it's talking about the over extraction, so this is implying that you're using more than is being replenished. So one of the main things that would happen in this case, or in such a scenario, would be the lowering of the water table. So once there'd be over extraction from the groundwater resource, the aquifer, you'd find that the water table gets lowered, because remember, the water table would be representing the maximum height of the underground water storage, right? So if you're constantly pulling from the underwater storage. You're pulling, you're always taking out. It's not being replenished fast enough. The water table is gonna be lowered. All right. That's what's gonna happen. The water table is gonna be lowered. And the explanation that I really have here, so building off that, it would be that the soil also in the saturated layer becomes thinner as the water resource is depleted. So remember that the soil would be saturated, or rather overly saturated. And so it would sort of expand. Now you're pulling all the water from from this area, and you're pulling and you're extracting. The soil is now gonna eventually contract, as well as it's gonna start to contract, as well as the resource, the water resource, the water level is gonna recede as well. So the water table would be lowered, so automatically. And then another factor or description would be that it could cause land subsidence. So could anyone tell me what that could possibly mean? Land subsidence. Anyone have an idea as to what I'm referring to when I say land subsidence?
You mean like the sinking of the land?
Right. Yes. So, okay. So remember, again, with where the water table is, right? And if the water table is being lowered, because if it's being lowered, what you'd find is that the land could sink and or possibly even collapse if the water level goes even lower, because remember the water table would be providing this sort of support, right? And so if you're pulling out of this resource, it's not being replenished fast enough to maintain, its current level or its current height, right? You could see a case where the ground begins to sink or collapse. And this could also have further implications, such as damaging surrounding infrastructure, right? So that's also something that, you'd have to keep in mind. And of course, another one could be the further deepening of the cone of depression. And what this would basically mean is that the cone literally could possibly become so, I don't want to say the gradient that is shown here could become so steep to the point where and it could go deeper where it's at this point now where you can't get any water at all from the well, and you're just having this area that goes further underground. It's just, yeah. So
Miss, and
deepening.
this could just like cause like a drying up of like what like aquifers and so on. Like,
Yeah, that as well. So okay, so all right, this question now here. Outline one way in which drainage basin will vary temporally, meaning over time, and one way in which it will vary spatially over space. So any ideas for this one? How can a drainage basin vary over time?
Could time possibly be with like regards to different climatic seasons? So like
Right,
in
yes.
dry seasons, the river channel might not have as much water as compared to wet seasons.
Mm-hmm. Mm-hmm.
So, yeah.
Right. Okay, so yeah, that's a good one. And you could give examples for this one, right? So you could give example like summer months, right? Where it tends to be very dry. It there's obviously an impact of the amount of water that could be present in the basin. So of course, you'd be finding reduced likelihoods, or rather lower likelihoods of flooding events taking place, right? In most northern countries where they tend to have glaciers, for example, during, I think, as it's approaching like somewhere between like around spring to summer, like that transitional area time frame right there, you find that the glaciers begin to melt. And so, it releases a lot of meltwater that goes into the drainage basin. And of course, increases the amount of water that would be in the drainage basin. Spatially,
Excuse me.
yeah.
Just one question, just in case I want to like put some big words in the answers. Could I use the static chain in that?
Could
Like
you
that makes
go again? Go again?
sense. The static change. Does that when the glaciers melt?
Right, yeah.
Mhm.
So
I could put
so
that right.
yeah, you could use that, I believe. Yeah, because you'd be looking at also but the thing though is that the only thing I would say, or the only drawback I would say to using an example like that, is that those are more so changes. Well, I mean, yeah, it kind of would work because it would still be over time, just a lengthy period of time. So yeah, you could use that. So you just have to mention, that it tends to take longer periods of time, before you actually start to see the impacts. So I'll just put that in there to clarify. But yeah, it could work because it's still over time, still over time frame. Um, anyone has any ideas for spatial variation? Okay, so what I had in mind was that, okay, so as rivers tend to approach, like, well, not approach, but more so in the middle courses of the river, it tends to become wider. You could possibly start to see that in the middle sections, or for rivers within the drainage basin, within the middle sections or middle courses, right? They tend to become wider, of course, due to widespread occurrence of lateral erosion. So they could become wider. That was what I was thinking. Anyone has any other ideas for spatial variation?
Miss, I had the same idea in terms of that. So
Okay. All right. Okay, now this one here, storm hydrograph. So does anyone know what a storm hydrograph is, or can anybody tell me what a storm hydrograph is? Wow, it's a graph that shows, or rather depicts what? What does it tell you?
is
Shows
it
the
the
relationship between a rainfall event and river discharge.
Right, so yes, so you look at river discharge and rainfall events, right? Um, can anyone tell me the features of a storm hydrograph?
Miss, like you're referring to like the rise in limb and the peak discharge and stuff like that?
Right, yeah, so those would be features. All right, those would be features. So you mentioned the rising limb. If there's a rising limb, then there's going to be what type of limb? We have a rising on one side, the next side must be
The fallen limb.
right, okay. Um, what about um the time. There's a specific
Lag
number,
time.
right? The lag time. And there are two peaks that the hydrograph this depicts. What are they?
I know one is peak discharge,
Right?
but
Yes. So
I can't remember the other one.
yeah, peak discharge and peak rainfall. Those two. Those are the two ones. And then you have some other I would say minor ones would be like base flow and runoff, or surface flow. But those I wouldn't say those are like critical, but especially towards a question like this now that asks us to discuss two ways that a stream hydrograph of an urban area would differ from the stream hydrograph of a rural area. So for this now, we'd actually want to use these features that we spoke about or that we just mentioned to, explain how they would differ. So one of the first things, what is a typical characteristic of an urban area? Like when you think of urban areas, what do you think about?
There's a lot of impermeable surfaces like buildings
Right.
and streets.
Yes. So lots of impermeable surfaces. So if there's a lot of impermeable surfaces, right, and the water can't flow, the water just it won't be infiltrated, right? It's not going to be really absorbed into anything. What's gonna happen? It's gonna just flow over the land, right? It's gonna literally flow on the surface, right? What could this mean as it relates to the rising limb? Would it be steep or gentle?
Steep? It would be steep.
Right, yes, it would be steep. So what you'd find is that, so the first point that you could make note of is that urban areas tend to have a lot of impermeable surfaces, right? And they have low rates of infiltration, and this promotes rapid surface runoff. And this automatically results in there being like an increase in the height and the steepness of the rising limb of the storm hydrograph. So that's the first one. And then, of course, the opposite would happen for rural areas where, because they have more vegetation, they have more soil cover, right? They tend to have more exposed porous materials. The water would basically reach the river channel much slower, creating a gentler or a less steep rising limb, more gentle, less steep rising limb. So that would just, so for urban areas, there's a steep rising limb because of, impermeable surfaces, like, so yeah. And then, so now if you're having rapid surface runoff in urban areas, that would automatically mean that the lag time would be much shorter or longer. So remember lag time would be the time between the peak rainfall and peak river discharge, or the peak flow. So if you're having rapid surface runoff, the lag time in an urban area would be much shorter or longer.
Sorry, which area?
Urban. The lag time for the
The
urban
lag
area.
time in the urban area would be shorter.
Right. Yes. Shorter lag times. Shorter lag times. So those are the two main ones I could say would be, you could readily describe as it relates to storm hydrograph. Talk about the height or the steepness of the rising limb. We'll talk about the lag time. And of course, these are the main features or features that could help you to easily differentiate between the storm hydrograph of an urban versus a rural area. Okay. All right. I think there's another essay question, so we'll revisit that shortly. Okay, so I think we just have a couple more pages to go. All right. Okay, so distinguish between natural hazards and natural disasters. So this is that's a fairly good question. Does anyone want to take go at this one?
A natural hazard would be like a like naturally occurring phenomenon that would be like a threat to human life or property. Whereas a natural disaster, this would be like when that natural hazard then causes like widespread disaster or whatever the case may be, which would need or which would cause for a need for like international aid and so on and so forth.
Right, right. So the key thing to remember, the key thing I would say if you ever come across this question and you're probably stuck or you can't remember, just keep in mind that the hazard is the potential or the potential threat of an occurrence, right? Of the occurrence of a physical event. So it's a potential threat, right? And then the actual disaster itself is now the realization or the actual occurrence of this hazard. It's now taking place or has taken place and has resulted in negative impacts. It's not affecting people. It's not affecting your property. It's not affecting, all sorts of or aspects of human life. Okay, so now this image here is a satellite image before and after an event. So what disaster do you think is depicted here?
Flash flooding.
Pardon?
Flash flooding.
Flash flooding, yeah, that could be one. I had in mind riverine flooding because I think this looks like a river to me.
Yeah, miss, I would say the same.
Yeah,
I
because
just probably would have put flooding.
yeah, flooding. So yeah, it's definitely some sort of flooding. But because I figured that this would be a river here, because as you can see, like you're seeing, meanders, you're seeing this sort of looks like, I don't know, like some lake or some sort of catchment area here, that shows poor drainage or something up here. So I was thinking it would be more, because this definitely looks like a river here in the before picture. Definitely looks like some sort of river. So that's the flooding, riverine flooding. So yeah. Of could be could put flash flood as well, but I'm not sure if I guess it could work, but I think I'd prefer riverine flooding or just leave it as flooding. Um, but yeah, with some type of flood for sure. Okay, so now this question here is asking one process that could have caused the disaster named above. could have caused the flood disaster named above. So technically, we could talk about one for each of these, right? Could give one climatic reason. There could be one geomorphic reason. There could be a man-made reason, of course. So let's see. Can anyone give me a man-made reason for this flooding that could have taken place here?
Could I say like man-made levees? Or is that
Levee. Why do you think of a levee?
actually I forget my train of thought. Um, I don't know. It's a man-made um thing. So that was like the first thing that popped into my mind.
Okay. What about a dam?
Okay. A dam would be reasonable because it is
Yeah.
larger than a levee, realistically.
Yeah. So a case where there could possibly be like the dam could collapse, or it could have like some large scale infrastructural damage that could have caused, like magnitude, like large amounts of water to just, be released, could cause something of the sort, a flood of the sort. Climatic is definitely an easy one, I would say, because, could be anything that would basically cause heavy rainfall. Anything, hurricane, could be tropical disturbance, any storm activity that brings heavy rainfall, right? Does anyone want to have a go at possibly a geomorphic example?
Would geomorphic be like landslides?
Okay, yes, a landslide could trigger a flood. Or you could look at things like, if there is, let's say, I think that I don't think this one would be more so in the Caribbean, but like if there's, let's say, a rock avalanche or something like that on a nearby mountainside, and if you're getting large boulders or, large pieces of rocks just falling into the river, for example, right? It could sort of push or create like this massive um removal or massive push or flow or whatever of water like downstream. So that could be one geomorphic. That could be a geomorphic example right there. Okay, so now mitigation activities that governments could employ to reduce the impact of disasters such as the one above. Now, I'm not sure who it was that said levees earlier, but that could be a mitigation effort here, right? The construction of artificial levees along the riverbank or along, channels, or if it's even like a drainage channel or drainage canal or something like that, or areas or conduits that have been created to channel water away from the surface or from settlement areas. Governments could construct these artificial levees, place them on the riverbank or on the sides of the conduits. They could, of course, one, they could be built of like impermeable material that water can't really flow through, as well as they could also help to increase the depth of the channel or whatever it is that the water is flowing through. So instead of it flowing over it, it's more so being forced to like flow along a specified path. So
Excuse me. If they
yeah.
increase the depth of the channel, wouldn't that like make it more problems because the land would be susceptible to subsidence?
Um, It wouldn't be the land that would be subjected to subsidence. In the case of a river, what you'd have is it would cause more, well, it's more so with the natural levees though. But no, I don't think it would cause subsidence because you'd just be constructing it along the riverbank, for example, right? So what you could possibly find happening would be just more erosion, could have more downward erosion, for example, or you could have some sort of erosion taking place laterally, but I wouldn't say subsidence.
Miss, I have a question. Would floodplain zoning be one of the mitigation activities that could be used by governments, as in they put out bans in specific areas so that people, so that it could literally like what's you read? It could help not destroy land property. Like if you don't have anybody living there, then you're not gonna have that particular socioeconomic impact.
Right. Yes.
But yeah.
Yes. Right. So they could put laws and legislations to prohibit construction of settlements or any form of infrastructure, right? And they could even prohibit the agricultural activity, whether it's rearing of livestock or actually cultivating crops within designated measurable distances away from the river, for example, because yes, the floodplain is a fertile area, but if you willingly know that the area is prone to flooding, floodplain, it's gonna be flooded at some point once there's a lot of rainfall or there are large amounts of water into the channel, then you can't really complain if you know this and you willingly plant or you really willingly build stuff there, and you know that there's a possibility that you could suffer major losses, right? So governments enforcing these things in place that you can't build, let's say, within 1 kilometer or 5 kilometers of this riverbank, right? That could protect people, and it could also save funds in the long run, save money in the long run. Another one, of course, could be the construction of floodwater diversions or drainage or storage systems that could redirect the flow of water away from settlement areas. Because in this diagram here, you are seeing that these look like settlements, or yeah, they look like settlements. You can see there's kind of like roadways here, and I don't think I have a pointer on this. Do I? I'm not sure if I have a pointer on this, but yeah, you could see like some sort of roadway. And this even right here looks like a bridge that would connect, one settlement to another across the river. So yeah, so putting things like that, like proper drainage in place, or methods that could, divert the floodwaters away into whether a canal or a pipe or possibly a reservoir for storage to, have water, I guess, to recycle or something. It could provide a controlled way of releasing or removing water away from the settlement areas. Okay. So now let's look at this question. Okay, this is another essay question. So as promised, we'll take like a 15-minute break, and then we come back and we do the essay questions.
Excuse me, one question before we go.
Sure, no problem.
For the geomorphic causes of hazard, government implementation that could be put in places like the construction of gabion baskets at the river, like at the banks of river course. Could that be one?
Wait, one sec. Could you go again, please? Because I can barely hear you.
Okay, so like for the mitigation
Mm-hmm.
that governments could put in place for the geomorphic causes of flooding, I wanted to say the construction of gabion baskets at the sides of river courses. Could that work?
I'm wondering if that would be a bit more. Wait, you said mitigation?
Yeah, to mitigate the, like to mitigate landslides from happening in the river course that will potentially cause flooding.
Okay, yeah, sure. Because that's a method, yeah, because you'd be putting up sort of like these barriers, right? That could um prevent, floodwaters like getting over or across. So yeah, that could work. But yeah, yeah, it could work, yeah. Yeah, yeah, yep. So I guess just ensure that you explain it. Um, yeah, but I think it could work because I mean it's used along the coasts. So I think if you explain it and say, well, in the case to prevent river flooding, you put them along, the river banks as a strategy or as a way to at least, reduce the effect of floodwaters. So yeah, that could possibly work. Um, any other questions? Okay, so all right, so we'll take a quick 10 to 15-minute break. And then 15-minute break, yeah, because we've been going at it for almost an hour and a half. Um,
Yes, we can stay on the basin, right?
yeah, of course you can stay in the meet. Um, I'm trying to see where does it still say that this meeting is being recorded? I'd like to pause it so that it's not running. Okay,
Yeah, miss, it does still say it's recording.
okay. Okay, so let's get back with the recording. All right. Okay, great. So we could start from this question and work our way back up. So this question says rather, in recent decades, impacts associated with earthquakes have increased, and they ask us to write an essay to discuss this statement and then basically include in your response 3 factors which may lead to an increase in the impacts of earthquakes on communities. Okay, so I think this one is pretty, I don't want to say almost straightforward, I think. Because basically you're just talking about factors that could possibly or potentially cause the impacts of an earthquake to be greater. So you're looking at anything that could possibly cause people to be more susceptible to earthquake damages or damages as a result of earthquakes, or anything, that could that has to do with, I guess, construction or anything like that. So I'm not sure if any of you guys have attempted this question as yet, but do you have any ideas as to how you could approach it?
If they don't have any, like if they don't have any or if they don't practice evacuation teams or have knowledge of what to do during an earthquake, for example, like go under door frames or yeah.
Okay, so right? There you're looking at the knowledge of earthquakes and, you know, what to do in the event that an earthquake is taking place, right? So that's one. So you're looking at low levels of education as it relates to earthquakes and their impact. So that could be one. That could be a factor. And also you mentioned, you know, there being no clear or defined evacuation measures or procedures, right? Because what you'll find is that in a lot of buildings, or in most modern buildings, you tend to have signs that say, oh, you know, here's the evacuation route, right? With arrows, and it tells you where the exit points are. And in some more advanced areas, like for example, well, not more so advanced, but more like areas where you have a lot of you know, building clusters, for example, like let's say a mall, for example, right? You sometimes see that they have a map, right, that kind of shows the locations of certain exit points as well as you know, assembly points that people could, in the event of a disaster, they could, you know, go to. So that could be one. Core building codes for infrastructure construction, and the poor building codes, not just in the sense of, oh, you know, there's no regulation, right? But also over the years, you have building codes being improved, right? So if you can't have the same building code that you had in, let's say, in the country in 1850. That should not be the same building code that you have now in 2024, right? These are codes that should continuously be revised, right? To ensure that, you know, as new construction materials are coming onto the market that are more, you know, sturdy, that are, you know, more reliable, right? Once these are coming into the market, you should be pushing and prompting for them to be incorporated into new building designs, right? So you can't expect to have the same building procedures and standards from the 1850s now in 2024. And also building codes as it relates to, you know, infrastructures that are to accommodate large population sizes, right? So for example, the building codes relating to an apartment complex, right? That let's say it's a high-rise building. It's supposed to have however many floors and should have like a large capacity as it relates to density, right? You need to be looking at how these buildings are to be constructed and with the right materials to ensure, you know, that the building wouldn't be easily compromised, right, at any point before the disaster or after the disaster, right? And even should it be compromised during or after the disaster, there should be a level of reduction, right, in the amount of, in the sorts of damages. Because, for example, I'm not sure if you guys saw a lot of, I think it was a Syrian earthquake that happened the other day, where even buildings that were so high just basically crumbled to the ground, right? So things like that, building codes continuously have to be revised, especially as innovation is bringing along, you know, more reliable materials, and persons are finding different ways to construct things that have you know, minimal effect on the environment. So things like that have to continuously be taken into consideration. Does anyone else have any more ideas? Or okay, so another point that I had, or another factor, would be the large increases of informal settlements in the global south, right? So these informal settlements often take the shape of, you know, slums, right? They could be, you know, just poor construction of just basically you just find somewhere and you just put up like in Jamaica, like zinc or, you know, boards or anything like that, right? And they're not constructed well. they, of course, never had any permits to construct in the first place in some instances, right? And so they tend to be poorly built, and they also tend to be overcrowded. So like in a lot of inner city areas, you find that, you have one plot of land, or one plot of land, and it's housing like 15, 20 people that it wasn't made to accommodate, right? So of course, in the event of an earthquake, right, it's already being poorly built and then being overcrowded on top of that. Should these buildings, right, or should these settlements sort of get destroyed or collapse and people are in them, right, you're looking at people being trapped and possibly being losing their lives because of just the whole idea of it being an informal settlement, poorly built, crowded, right? So things like that. So yeah, so from being trapped to losing their lives, losing limbs, things like that. Also, a very important factor could be the proximity of the community or the settlement to the epicenter of the earthquake, right? Because does anyone know the definition of the epicenter of the earthquake or what it refers to?
Is it not the point on the surface that is right above the focus where
Right.
the earthquake originates?
Right, yes. So it's the point on the Earth's surface that's directly above the focus. And if you're ever wondering if you're ever just remember that the focus is on the ground at the point at which where, the fault is, or, where the earthquake is generated, but the epicenter is the point on the surface, right? And this point is where the seismic waves are felt the strongest, right? So if you're having a community that is literally basically the epicenter of the earthquake, or it's like a walk away from the epicenter, you're gonna find that the impact the impact, or rather, the effects of the earthquake would be the strongest there, as opposed to another community that is located much further away from the epicenter. So those are some of the factors that you can keep in mind and that you can like you know, write and explain around. So I'm not sure if anyone else has any ideas that could represent a factor.
No, miss, I don't think I have anything to add.
Okay. So the next question then in that case should be the one. Well, let me see, I think this is it. Okay. So three reasons why settlements and arable farming may be difficult in an area that is predominantly limestone. And then they ask, of course, including your introduction, 2 characteristics of limestone. Okay, so I think 2 characteristics of limestone. First one, okay, so the first one, of course, is that it's easily weathered. Does anyone have another one? Limestone. Think of it. High porosity.
Yeah.
Yep. Yep, that's one. High porosity. Okay, so that's 2 right there. So it's easily weathered and it has a high porosity. And what does high porosity mean?
It absorbs water a lot.
So it absorbs or it easily allows water to pass through. All right. So, okay. So, right. So those are the 2 characteristics. Now, 3 reasons why settlements and arable farming may be difficult in an area that is predominantly limestone. So, what are the first reason I would like us to look at is, okay. Is the paper still showing on the screen?
Yes, it is.
Okay, great. Okay, so let me ask, what's like the main mineral that is found in the main mineral compound that is found in limestone?
Calcium carbonate.
Correct, right. And it being a carbonate would suggest that would it be more basic or acidic?
Acidic.
Acidic?
Yeah, I think so. I don't know.
Calcium carbonate?
Wait, no, but when it does react with water, I think it becomes acidic. So what is that?
Yeah, right. When it reacts with water, it becomes acidic.
Wait,
So that would mean calcium
it's
carbonate. It's a base, it's
okay,
basic.
okay. Understood.
Right. Yeah, so it's a basic compound. And it being a basic compound would mean that it has like a high pH, right? So what this means for farming is that the high presence of, or first of all, the soils that will be formed on top of limestone rocks, or yeah, so if you have an area that's just fully limestone, the soil that would be produced would be rich in calcium carbonate. So this means that it would have a high pH content. Now, this high pH content would make it basically, it's a basic compound, or it's an alkaline substance, right? This now reduces the availability of nutrients, or it reduces the presence of many nutrients, such as like your macronutrients and your micronutrients. And we're looking at macronutrients in terms of nitrogen. Nitrogen is one that would be depleted. And there's another one. Nitrogen. What's it? Nitrogen. Magnesium would be magnesium as well. Yep, magnesium. And there's one more I could think of. Would it be, think probably potassium? Think potassium. So yeah. So you'd be looking at those macronutrients like nitrogen, potassium, and magnesium. Their levels would be lowered in a highly alkaline soil, like soil that would be rich in calcium carbonate. So, and then for like micronutrients, those tend to be readily and easily available and in more abundance in soils that have a pH that's leaning towards the more acidic nature. So like things like manganese, zinc, iron, yeah, those. So the levels of macro and micronutrients will be very low in calcium carbonate rich soils, such as those that will be produced as a result of limestone rocks. No, there's another factor that you could talk about, right, would be the fact that limestone rocks, right, have a higher, or they're more susceptible rather to the formation of sinkholes, right? Now, can anyone tell me why a sinkhole could be detrimental? Or would make someone not want to live in a particular area?
Miss, could you repeat that point, please?
I was saying, okay, so the next point I was saying was that limestone rocks are susceptible to sinkhole formation. So I was saying, why would someone not want to live in an area if they find out that there's a sinkhole, or there's a potential for sinkhole formation?
Their infrastructure won't be supported.
Right, correct. Because basically what happens is that when you have basically a limestone surface, right, we know that you'll have disappearing streams and streams that resurface or reemerge at some point, right, along a profile, right? So if the stream should disappear and now it goes underground, it's flowing between, the cracks, the crevices, the joints, everything like that through the rock, right? And it's slow, there's gonna be processes of weathering and erosion that will taking place, right, as a result of the water action. And as the water is gonna erode away the rock, it's basically gonna cause like reduced support above and of course below the stream as well. So in the case of above the stream, if it's eroding the rocks above the stream, and remember, above the stream is basically, because it's a disappearing stream, above the stream, you'd be actually looking at land, or it would actually be land. If it's sort of eroding, it's gonna weaken the support that whatever infrastructure that you've built on the land surface is gonna have. So it's literally gonna cause there to be a depression formed. So the land will eventually be depressed and depressed and depressed until it literally collapses and you have a sinkhole form. So you literally can there have been cases where the land, luckily, because people haven't been living in the area, there haven't been much damage. But in an instance where someone actually builds in such an area, they literally could just come by the next morning and like see the house not there or the building not there, because the sinkhole just happened. And in cases where the ground is not being monitored, or activities underground aren't being monitored, you could literally just have it being so abrupt that no one recognizes what is happening, and it's just like one abrupt change on the surface. And the thing with sinkholes is that you can never really know how big the sinkhole is going to be. You just know that there's a likelihood and there's a high possibility for it to happen. So to prevent any such possibilities or occurrences or damages, you'd want to just not build there. And of course, the prevalence of the formation of limestone pavements. So basically, limestone pavements are, I would say, large expanses or areas of exposed limestone rocks, right? And what happens is, it's because limestone, as mentioned earlier, is something that's easily weathered. You have, rainfall, you have water, all of these things, especially atmospheric conditions, that basically weather away and, break up the rocks. And you basically have the formation of what are called clints and gripes, right? So you basically see like the rock has sort of been divided or separated in certain areas with deep grooves, right? And if you're farming, should you be farming on a surface such as this, or you've built your house on this, it could cause major structural damage to your home. And of course, it could cause, the land that you're farming on to become unstable, because if it's literally causing, if the rocks are literally being broken apart and the spaces are expanding between them, right? You're gonna have, areas where soil is leaving the surface and like falling into these deep grooves. You could have crops if you're farming like vegetables, for example, or even possibly in some cases where you've just planted new tree crops or anything like that. The roots literally could become unstable. So you wouldn't want to really farm or build your house in such an area. So yeah. Does anyone else have any other ideas that they think that they could possibly think of, or do they have any questions regarding that question just now?
Could like a lack of nutrients be something? Because like realistically speaking, limestones aren't really like nutrient filled, like as compared to soil or something, you know?
Like, yeah, right.
Like
So
lack of minerals and stuff, you know?
right, yeah. So they have low levels of macro and micronutrients, especially the calcium carbonate rich soils that would be produced as a result of the limestone rocks, the underlying limestone rocks. So yeah, that is definitely correct. Any other questions? Okay, so I think the next essay type question was this one right here. Okay, so the urban land use model. So again, this one was for Hoyt's sectoral model. So for this part now, it asks us to discuss how the urban model in figure 3 explains the segregation of people based on economic status. So the first thing it asks us to do is to provide a brief outline, right, of the model as the introduction. So I guess for this part, you could basically, if you want to give like a brief history of the model, right? Could tell who created the model, what year possibly was created. I believe it was 1939 was the year that the model was formed, right? And it basically, again, shows you could even use back some of the same words, segregation of people based on economic status. It also, suggested areas of particular human activities, such as like manufacturing industries would be located. And also it used the main it identified, or rather used, economic status to judge where people would live, or vice versa, used where people would live as a measure of their economic status. All right. So just a brief introduction on the model. If you're someone, I know a lot of times with geo, if you can draw the diagrams and label them, that's some added marks right there. So even for this one, it's the bonus is that it's already there. So if you could remember the labels, what goes where, right? And we did a couple of them earlier, the high class residential in here, sector 5, right? The wholesale light manufacturing in 2, CBD in 1, right? Middle class residential area in 4, and then the low class residential in 3. Right? So things like that. So you could even draw a diagram as well to accompany, whatever it is that you're gonna talk about. So now into the here where people live. So again, now here you basically be talking about the economic status and how these determine, or as per Hoyt's model, it would determine where people would live, right? So in 3, that would be where the lower income or low class residential neighborhoods would be located, right? So these are where you basically be finding people that don't earn within certain income brackets, right? They probably don't own their own motor vehicles or cars, anything like that. They can't really afford, spending a lot of money on transportation. They probably work long hours, for example, in the factories or in the manufacturing industry. So, being close by or living close by would be an added benefit. And of course, them not being able to earn within a certain income bracket would mean that they would need to prioritize, cost as it relates to their living expenses, right? So you're looking at, them having a need for cheaper rent or cheaper housing costs, right? So yeah, that would be something that you'd use to classify the low class residential. What about the high class residential neighborhoods that would be located in sector 5? Can anyone talk about that one?
Miss, I think the general consensus of it, he was basically saying that the reason why higher class persons would choose to live where they did was because that they would have had like private cars and so on and so forth, and they could afford transport. So that would have influenced them to, occupy a specific area.
All right. Yeah. And it would kind of be this for the middle class, it would kind of just like be right there in, the middle, right? So it's they kind of probably want, an area that is a bit further away from industry and possible pollution, right? And they probably have they might not have their own cars, right? But they could be able to spend a little more or have the freedom to spend a little more on transportation, right? And so you possibly find that they have more reliable, like probably public transportation, so like rail systems and things like that. So yeah, that's what I would say. And as you said, again, the high class, people would have their own vehicles. They could travel not only just for work, but also entertainment purposes, right? Anything that they would really want. They're away from a lot the noise, the hustle and bustle that comes with living in the city or close by to a city. Right. So through the classifications or the use of the different sectors to represent neighborhoods, right? Hoyt not only spoke about just the economic status, but it also speaks to the preferences or the distinct features that come with wealthy versus poor lifestyles. And then the relevance of the model to urban land use in a named developing country. Now, I don't think that this model could apply to any developing country. So I feel that it's more so irrelevant because it's a couple of things. A lot of these models, they're outdated, of course, right? And they don't accommodate, or they don't represent the dynamic level of urban growth or population growth that takes place within countries, especially countries of the global south, because a lot of these models are based off American or European cities, and that's not really how cities in developing countries or the global south as a whole tend to develop, right? Also, Hoyt's model doesn't really take into account the fact that not all businesses are gonna want to be located in the central business district, right? Not all factories are gonna always be concentrated in the sector that he outlined, right, for manufacturing industries, right? You tend to have nowadays businesses, because there have been improvements in transportation networks, right? So you have businesses, whether it be offices or factories, being located in particular areas. And as it relates to factories, for example, they tend to be located closer to the natural resource of importance, right? So, for example, you're not going to find a bauxite plant located in not necessarily the heart of a city, but close by to like the main city of a country. It might be located close by to like a smaller city, but it's not going to be located towards like a main city or a big city, right? And they tend to be located closer to, right, so as I said, the natural resources, and also they try to be located close to ports or harbors or areas that they can easily transport, or rather facilitate export of their refined materials. So yeah, it doesn't really accommodate for a lot of the changes or the dynamic way in which developing countries grow. And also they tend to, a lot of these models, especially Hoyt's model, it was built on the whole idea of the rail transportation, so trains, right? So they never really prioritized the possibility or even looked at the possibility of people in these potentially low income areas or even middle income areas being able to actually have cars. Because if you look at a lot of areas within the global south, right, people have their cars. They might not be very wealthy, right? But sometimes they still have, a vehicle. It might not be the latest vehicle, but they have some level of transportation, especially different types. So it might not just be a vehicle in terms of a car, but it could be a motorbike, right? So things like these. And then also there tends to be like the central business district, the size of it's not one set size, right? As we're seeing in urban areas of the global south, or just like in general, they tend to expand, right? So you find that a lot of times what you thought was at one point the central business district or a central point has now expanded, or it's like getting larger and bigger and bigger. So you find that you have the creation of a lot of zones, like for example, edge cities, right? And edge cities are basically, it kind of has like a mixture of business spaces like offices and retail areas, as well as it also has residential areas. So you kind of find that these models, they don't tend to showcase or highlight the growth of urban areas within developing countries or the global south. So I mean, you could use any Caribbean country, Jamaica, Trinidad, any one of these areas to really, explain this. I'm not sure if anyone else has anything else to add for this question.
No, Miss, I think you basically covered it.
Okay. All right. All right, so I think what's left for this paper now is a map work. All right.
Miss, I think after we finish that essay, I'll have to leave because I actually have somewhere to be in the morning.
Oh,
Not school,
yes, right.
I have nothing to right yet.
Yeah.
So once we finish the paper, I'll take my leave.
Okay, I think you had a particular topic that you wanted to run through. Let me check by the chat.
Yes, I had like, I think a few,
Okay, hold on. Let me
5 topics.
the chat. Okay, the chat is okay. All right. So, all right, so the essays kind of out of the way. I mean, I think the majority would have done CSEC geography. So I feel like the map work questions won't be that difficult. It's more so gonna be, identifying particular features or things on the map. So it won't be that strenuous. But let's see okay, so you talked about population change, population structure. Okay, so what exactly would you say in population change? Because it tends to be like a broad topic. So what part of population change would be like
Miss, I would
made?
say like it's more so like the calculations.
Mm-hmm.
So like population growth rates and like your doubling time and so on and so forth, honestly.
Okay. So it's the calculation. So
Yeah.
okay, so all right. So the formula, what's the formula that you have for population growth rate?
Miss, that's a great question. Actually, to enter a formula, I wait just now. I think I might have one.
Think it should be, I think it should
Population.
be something like N over T or something of the sort.
Is it not the number of people multiplied by the area? I'm not sure. No, wait, that's like something else. Oh no, that's population density.
Yeah, that's density. Area, anytime you're including the area in the formula, it's more than likely going to be density.
Uh, oh,
Yeah,
actually, I have a formula for this, and I actually remember how to do it, which means that this is not what I needed help with.
right. Yeah, because I would say that as it relates to the calculation, it's just more so remembering the
Yeah,
formula and applying them. So
yeah. So
yeah,
it would not
just
necessarily be that, but the other topics like the fluvial processes and stuff like that, I would have liked to run them over before I had to leave.
okay. So
But
fluvial processes you're basically looking at processes of erosion,
mhm,
transportation, and of course deposition, right?
mhm,
So fluvial erosional processes, you're mainly looking at like hydraulic action, which is of course, the water action, right? Hydraulic, right? So water action on the bed and banks of the river channel, right? So you're looking at where the water's shear force, or just the force of the water in general, is causing the rocks on the riverbed and in the banks to basically be eroded, right? And then for corrosion is another one. That one is basically where the material or the load that's being carried by the channel has sort of this abrasive effect on the river channel itself. So think of like pebbles or rocks, right? They tend to, if they should they get trapped in the riverbed or in the side of the riverbank, for example, right? They could literally swirl around and they move around and they tend to sort of that action basically is an eroding type of action because it's now kind of sort of digging into the bank or the riverbed and it's eroding away and causing the area to be removed. And of course, the water is literally carrying away the material. And then corrosion is basically chemical erosion. So here you're seeing that like the water in the channel starts to interact with a lot of the minerals, right? And what it could literally do is it can change the chemical composition, or it could literally remove a lot of these minerals and turn them into bring them into solution. That would literally be corrosion. So you're thinking of let's use, for example, limestone. And we know the process of how, like, when water interacts with limestone, you get the weak acid, carbonic acid forms, things like that, right? So just keep like things like that in mind. And then for attrition, that's basically where the materials in the river, so like the rocks and the pebbles, they're colliding with themselves, right? And what happens is that they tend to become smoother. So the rocks become smoother because like more upstream, you tend to have more angular type of rocks. And then as they move downstream, they tend to kind of become more smooth and kind of become more rounded. So yeah, so it's basically just those four processes: hydraulic action, corrosion, and attrition. Those are like the four main erosive processes in rivers. And then as it relates to transportation, you're looking at the type of load. So is that the river is carrying. So is it carrying load in suspension? And these tend to be like, as I was mentioning, the minerals that would be like sort of like small minerals, or in the minerals that would be in solution. So those would be like your suspended load, your solution load, solution load. Solution load would be your minerals that are in solution in the water. And they literally get to flow right along the river straight into the sea, or if the river is emptying into a lake, into the lake, or wherever the mouth of the river is, they travel the furthest. And then of course you have your suspended load. This now would basically be like, think of clay and silt. So your fine particles that could probably be more easily seen, like if you have like let's say they kind of make the water look like murky. So like, especially if it's like following like a heavy rainfall event or a flooding event, for example, and the water appears like murky. So that would be like your presence of clay and silt. And they also travel a far distance because they're carried along in suspension. They tend to be very light. And most of the deposition that you'll find happening downstream, so think of like on deltas, right? Deposition in delta environments, or deposition in areas like more so areas of the lower course of the river, right? You tend to find that these silt and clay materials tend to deposit, right? So even floodplains, for example, they tend to be an accumulation of these fine silty and clay type materials. And then the final one would be like your bed load, right? These would be the large boulders and the large pebbles and the rocks. And these tend to basically move either via traction, where they roll around on the floor of the riverbed, or they could move by saltation, which is kind of like bouncing or jumping along the riverbed. So 3 types of load: solution, suspended, and the bed load. Those 3. And then as it relates to deposition, again, this is just basically where you find that material settle. So this can happen due to a variety of reasons. And one of the main ones has to do with like the velocity of the river. So wherever there's like low velocity and low energy, wherever the river has low velocity and low energy, the depositional processes increase. So you find that the river will literally, in layman's terms, drop its load. So it would literally release whatever sediments or particles it's carrying because it doesn't have the energy to carry it any further. So that's why in certain areas of the river, you might find large boulders just settling in particular areas because the river doesn't have enough energy to carry these big boulders anymore. So what would it take to move such particles again? It would have to be an increasing the velocity and increasing the energy. And you'd find this tend to happen when there's like heavy rainfall events, right? Things like that would cause the particles to be moved again along the river profile. And of course, you could think about the volume or the depth, the volume of water that's in the river channel. So as it relates to volume, right, if the deeper the channel, the more, or rather the larger the load that it can carry in terms of the size. But as the volume is decreasing and there's less water in the channel, it's now gonna only be able to carry smaller and finer sediments or load in solution. So suspended load and solution load would be the ones that would be carried as the channel volume decreases. And
Okay.
of course, pardon?
Oh, I was gonna, as soon as I was gonna say that I understand that whole entire concept that you just explained. And I was gonna specify that under the hydraulic cycle that I really just wanted to know about the storm hydrograph because I realized I didn't specify enough. So I just wanted to tell you before you move on.
Okay, so you remember the question that we did earlier relating to the storm hydrograph?
Yes, I
We
do.
spoke about rural, right? We spoke about rural and urban. That's pretty much what you'd be looking at. So I think, if you if you go on Google and you Google a diagram of the storm hydrograph, I think I could just, let me share my screen, see if I could find um, a diagram of a storm hydrograph. So the main features that we discussed earlier, is new share. The main features that we discussed earlier. I'm not sure how these copyright laws work, but hopefully. Do you have the study guide, the CAPE study guide? I think
Yeah,
it
I
should be.
do. I have a picture of it.
Okay, great. You have a
Yeah.
picture because I'm not sure how these copyright laws work. So I wouldn't want to do anything. Right. So are you still seeing the CAPE paper, or did my screen go blank?
Yeah, I am.
Okay, great. So with the storm hydrograph, you're basically identifying the features. So I think you should have like the rising limb, the falling limb, the peak discharge and peak rainfall, lag time, things like that. As it relates to understanding the storm hydrograph, it's basically having an understanding of what it would look like in a rainfall event in a particular area. So if it's an urban area, for example, you're gonna see there'd be a short lag time, right? And that would mean that there's also, you're able to see a steep rising limb, and the distance between, or rather the time between peak rainfall, which should be indicated by the highest rainfall bar, to peak flow or peak discharge would be by the point or the peak of that curve, that has the rising limb and the falling limb right there. There's going to be a peak always. So that's pretty much where it goes to like understanding the storm hydrograph. Not sure how else would be a better way to explain it, because really and truly what you're doing is you're identifying how quickly, or yeah, more so how quickly like a flood event would take place in a particular area based on the time between peak rainfall and peak discharge. So it's just like having that in mind. So if you know that it's a very, very short lag time, it's more than likely going to be an urban area. If you see like a very steep rising limb, it's an urban area, right? And then
Okay.
the opposite. And then
Okay.
population structure, that's another broad topic. Again, are you like looking in terms of
Well,
LCDs versus MCDs, like
I think that was
NBC, sorry.
another. I think that was another topic that I probably thought I didn't understand, but in as much as you like went over certain things, I feel like no, I kind of know that I probably know more than I thought I did. Sorry, I don't know if that makes sense.
Yeah, because
Yeah.
population structure in less developed countries versus more developed countries, so LDCs to MD versus MDCs. You're basically looking at, I think earlier we spoke about high fertility rates, right? We spoke
Yeah,
about,
we did.
yeah, so in less developed countries, you'd be having higher fertility rates. You'll be having like a larger youthful population, right? You're
Right.
having, yeah, so you could use population pyramids, for example, to help you to understand that. So with an a less developed country, you tend to have, it's more what would be the best word to use? I think probably like a more triangular shape, where it tends to have a wider base, and then it starts to decrease going up, right? And then you could the way or the shape of this population pyramid could reveal certain things, like for example, life expectancy, right? It could reveal longevity, right? It could also reveal like even let's say it's a less developed country, but the base isn't as wide as you expected it to be. That could be an indication of high infant mortality rates, for example. So right, so things like that. And then as you know, there starts to be a transition into it becoming a more developed country, you start to see the narrowing of the base of that population pyramid, right? You start to see where fertility rates are dropping. So the base becomes smaller because now there's less of a youthful population. You're seeing where there are higher numbers or higher populations within the working class group. So, your 20s, 30s, 40s, right there. And you're also seeing a wider or a larger than normal concentration of people that's like above 60, above 70, right? So that would indicate a more developed country, because now you're having an aging population, right? So if you should see the population pyramid for Japan, and more so Japan, let's use Japan. If you should see the population pyramid for Japan, it wouldn't have a wide base at all. It would literally be, the base is very narrow, and the top it's much wider. So it's kind of looks a little, quote unquote, like it would topple over because it has such a narrow base. And then also population structure again. I'm not. You could probably even look at urbanization, I think, as another one, because there tends to be a high concentration of people that tends to live in cities. But the thing is that in the less developed countries, you're having large, like it's growing at a rapid rate. So it's like this rapid growth of people that are living in the cities of the less developed countries. And it tends to cause a lot of social issues as well as environmental issues. And we spoke about the presence of informal settlements earlier. That tends to be a very common problem in the cities of the global south. So in the developing countries, you tend to find a lot of housing crises as it relates to, informal settlements, as well as, they're just being low quality housing. Sanitation is an issue because the cities in the less developed countries are so densely populated that a lot of the sewer systems that have been put in place can't manage or can't really easily or comfortably accommodate, right? The large influxes of sewage that's taking place, or the large influx of sewage that's taking place, right? And in some cases, especially in like Kingston, for example, you find that a lot of the sewage, it's not really treated to such a very high degree, and it's being released into, the surrounding waterways, like the Kingston Harbor, for example. So you find that there's an issue as it relates to sanitation and the release of like sewage into like, waterways and or water areas, for example. And then of course, pollution, air pollution, solid waste pollution. So things like that would be like your typical like characteristics that you'd be seeing taking place. What else could I think of as it relates to population structure? I'm not sure what else I could think of as it relates to population structure. I'm not sure what else I could think of as it relates to population structure at the moment.
I think that would have covered it. I
Uh,
believe so, because it's just supposed to show like the structure of like, let's just say an Asian population or a young population or whatever the case may be. Well, from what I've learned, that basically reinforces everything.
yeah,
So,
so population and again, the demographic transition model, the
oh yeah,
DTM.
I know about this because I also do sociology. So
Okay,
we have that in sociology as well, yeah. So I know about that one.
okay, so all right, so you have an idea as to what if they should show you, for example, like a graphic of the demographic transition model and ask you which country could possibly be
Mhm.
in stage 2 or stage 3. Do you think you have adequate examples? Or
Yes, I
think
think so.
okay, so yeah, so just revise those because I'm not sure if they might do that this year, grabbing particular areas of the DTM and ask to expound on it. I think I've seen past paper questions that asked about that.
Yeah, I got a mock exam based on one of the papers where they brought like a table and they had to say like which country was in whatever particular stage of the DTM. So
Right. Yeah.
yeah.
So I'm not sure if I think someone had sent I saw a question in the group chat.
Uh-huh.
Question 6C. Let me see if I can find it back. I think it was a 2011 paper. Let me see if I could find that. Let me see if I can find that paper just now. 2011 should be somewhere here. This should be the 2011 paper. All right, so I think it was question 6C that they had asked for. Okay. Explain why there is no volcanism. Is a person still here? Person who asked for 6C?
No, I don't think so.
Okay. I think it was Zara. So, all right. So basically, what it's asking about is, no volcanism at transform faults and zones of continental collision. All right. So basically, for transform faults, all right. The main thing for volcanoes to form, or well, main things rather, you need to have a zone of subduction, right? You need to have a subduction zone, or you need to have some sort of, I'd say in this case, since they said continental collision, you'd need for the continental collision would signify converging plate margins, right? So for like volcanoes, you'd need at least some sort of divergence to be taking place in this scenario, because if the transform faults are basically them moving side by side, right? They're kind of rubbing against each other side by side, and that's what creates earthquakes. There isn't any subduction taking place for any molten material to rise to the surface, and also there isn't any, yeah, there isn't really any opening for molten material to get to the surface. And then for continental collision, it's more so them literally, as it says, colliding, right? So one of the main things that you have to think about as it relates to volcanicity is, how is there any way for magma to get to the surface? If there's no way for magma to get to the surface, there's literally no way that a volcano could be created. All right, there'd be no way for you to get lava to the surface. There'd be no way for volcanic rocks to be found, because there's literally no, you're not getting any form of molten material to the surface. So that would just be basically the thing, the main reasons that I would say is that, one, at transform faults, there's no subduction taking place at transform faults, right? And zones of continental collision, you're not really finding any sort of crustal openings that could bring molten material to the surface. And then I think, yeah. Does anyone else have any other topics, since it's getting pretty late? I'm not sure if everyone here is.
But I think everyone else left, so.
Okay, so I'd assume then with that we're pretty okay then, as it relates to the past papers and the questions and stuff. So